Hello everyone, this is Sinjan again. This is the ninth video for my channel and third in line for the series of lectures which I have prepared and I'm preparing for ISI and other entrance examinations. As you know, the ISI exam is on 11th of May and the CMI is on 24th of May and JEE we have the April attempt. So I'm just trying to wrap up things and cover up things faster for your benefits. So today my focus will be again on the same topic which I had done previous day, that is symmetry, symmetric functions, or the main part of it, Vieta's relations. I will be starting with by doing some questions on Vieta's relations and then I will be moving on to symmetric functions, and we will be doing some interesting problems today based on these two, since these two take up a majority of the questions of polynomials asked in ISI and JE2. So yeah, that is it. Let's start up with them. We start up with some questions. Like selected. My reference book is again this one. Test of Mathematics at +2 level. So let's start with an easy one first. Okay, so what is my first question for today? It is given I have my equation, the basic equation. I will be just revising it once and after that I will be moving forward. Just let me write down the question. So the base plus c is equals to 0. This is my original equation. It's my initial roots alpha comma beta. So then we need to find out the equation. Find out equation whose roots are alpha square and beta square. Easy one. So before that, let me just revise it from the previous video, from the previous notes itself. Yeah, so beta's relations, very, very important one, crucial one. A relation, what is it? A relation between the roots of the equation and the equation itself. That is, we have a general polynomial equation f(x) equals to x to the power n plus bx to the power n minus 1 plus cx to the power n minus 2 plus dot 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 up till the term where we reach the constant. So the crux of beta's relations, for any polynomial to be formed, we need the, what is the crux, what is the main idea behind beta's relations? For any polynomial, we need two primary things: sum of the roots and product of the roots. Sum of the roots will be taken in different ways. How? First one single one at a time, second one two at a time, third one three at a time, and so on and so on. It depends on the number of roots the equation has, or the type of equation. That is, if it's a quadratic one, then we will only be needing sum of the roots taking one at a time and product of the roots. If it's a cubic one, then we'll be needing three things: sum of the roots taken one at a time, sum of the roots taken two at a time, and then product of the roots. For a quadratic equation, we'll be needing probably two things, of which the sum of the roots will be taken three times. One is taking one at a time, second is taking two at a time, and third is taking three at a time. So, and product of the roots, we don't need to generalize it, we can remember them by looking at the different cases. So my alpha plus beta, my first equation is for n is equals to 2. My equation f of x is x square plus bx plus c, and its roots are alpha comma beta. So my alpha plus beta would be minus b by a. That is, that my initial equation is x square plus bx plus c, where a is the coefficient of the highest order term, has degree term, b is the coefficient of the next one, and c is the constant term. So my alpha plus beta would be basically the coefficient of x divided by the coefficient of x square with a negative sign, that is minus b by a, and my product of the roots would be c by a, that is the constant term divided by the coefficient of the highest degree term. And if it is monic, then monic means my highest degree coefficient, highest degree terms coefficient would be 1. So my alpha plus, so my A would be 1, then my alpha plus beta would be minus B, and alpha beta would be C. Then the equation which we can form by using the roots would be f of x is equals to x square minus of alpha plus beta of x plus alpha beta. Now if we just substitute my alpha plus beta and alpha beta in this equation, it will be x square minus of bx by a plus c by a, and then it will be basically x square plus b by a plus c by a. I can take my a to be common and just multiply it in the numerator of all the terms. So basically what do I get? My f of x is coming to the original form, which is ax square plus bx plus c. This was the case for quadratic. Similarly, now we go for the cubic equation for n is equals to 3. F of x equals to ax cube plus bx square plus cx plus d. This is my general cubic equation, whose roots are 3. Cubic means 3 roots, so I have taken them to be alpha, beta and gamma. As usual, my sum of the roots would be minus b by a. Alpha plus beta plus gamma is also minus b by a. And now comes my second case, which is by taking products 2 at a time, that is alpha beta plus beta gamma plus alpha gamma, which can also be written under symmetric expressions as summation alpha beta. That is, we go on a cycle and just complete all the terms related by using the same format as described in the summation, that is summation alpha beta. That basically means we once take alpha beta, summation means addition, so alpha beta plus beta gamma plus alpha gamma, that is equal to c by a. And on the side, my alpha beta gamma is equals to minus d by a. One thing which is noticeable is there's an alternation of signs. So basically, whenever we are looking at an n degree polynomial, my main first summation, first we will be starting with the negative ones. So the first equation we should be getting would be negative, so first one would be negative, second would be positive, third one would be negative, fourth one would be positive. That means 1, 3, 5, 7, the odd ones would be negative, and 2, 4, 6, 8, the even ones would be positive. Equation found for the cubic one, again same, use the summations and the products. So x cube minus alpha plus beta plus gamma of x square plus alpha beta plus beta gamma plus gamma delta of x minus alpha beta gamma. Now for x is equals to 4, f of x is equals to x to the power 4 plus bx cube plus cx square plus dx plus e. So again summation alpha plus beta plus gamma plus delta, so that is equal to minus b by a. That means summation alpha is equals to minus b by a. Next we come up for alpha beta plus beta gamma, means we will be taking basically summation alpha beta, which is your c by a. Then comes alpha beta gamma plus alpha beta delta, which is ultimately 4 terms, which will be becoming minus d by a. That is product, that is some of the roots taking 3 at a time, and then comes my product, which is the alpha beta gamma delta. Sorry. So one question had we done, I guess. Yep, we had done one question. I'm sure all of you are clear with this. One quick revision of the main thing of this Vieta relations. Now time for questions, which would help us much more by applying the relation. So this is my first question, everyone. Just be changing the color. Let's start with green today. So x square plus bx plus c is equals to 0. My general quadratic equation is given, whose roots are given to be alpha and beta. Now we need to find out the equation whose roots are alpha square and beta square. Okay. So my equation is ax square plus bx plus c equal to 0. whose roots are alpha and beta. Very easily from Vieta's relations. I'm just writing it for the sake of your understanding, otherwise you can write it directly too. From Vieta's relations, alpha plus beta is minus b by a, and alpha beta is c by a. Okay. Now comes alpha square and beta square. Basically, we need an equation whose roots are alpha square and beta square, whose binary relations can be derived from the original beta relation. How? So for 2 and 4, to form an equation, my general equation would be basically your new equation. New equation would be basically what? X square minus of alpha square plus beta square of x plus alpha square into beta square equals my 0. Okay. So next, what do we need? We basically need our two terms, two things. Alpha square plus beta square is how much, and alpha square beta square is how much needed from yes. So my alpha square beta square is very easy. My alpha square and beta square would be basically your alpha beta's whole square. That means, which is your c by a and a's whole square. That's me, c square by a square. Now we need my alpha square and beta square. So what do we know about the whole squares? If I do the whole square of alpha and beta, that is alpha plus beta whole square, what will we be getting? We will definitely be getting two separate individual terms of alpha square and beta square, which would be with the positive sign. So we would need my alpha plus beta and alpha beta to solve for alpha square and beta square, and unfortunately both of them are given. So what do we do here? We need to look at his powers. Okay, so if it was alpha cube plus beta cube, we would have gone for alpha plus beta's whole cube. There also we would only be needing my alpha plus beta and alpha beta. So basically, since alpha plus beta's whole square, what does it give me? It gives me alpha square plus 2 alpha beta plus beta square. Gives me this. My alpha plus beta is how much? Minus b by a. This is my alpha plus beta is minus b by a. Minus b by a's whole square. Alpha square plus beta square is needed, so we just put it together and give a bracket. Plus 2 alpha beta is here, 2c by a. So my minus b by a's whole square is basically your b square by a square, and negative square is a positive number, so alpha square plus beta square plus 2c by a. So my alpha square and beta square plus beta square is basically your b square minus 2c by a square. This, just a second, it's 2ac. Sorry, I won't be writing it directly. Yeah. My alpha square plus beta square is needed, so that is your b square by a square minus 2c by a. That gives me a square, LCM b square minus 2ac. So ultimately my a square plus b square is b square minus 2ac by a square. And my alpha square beta square is c square by a square. So I need a quadratic with the roots of alpha square and beta square. So therefore new quadratic is what? It is your x square minus of alpha square plus beta square of x plus alpha square plus beta square equal to 0. So my x square minus alpha square plus beta square is how much? B square minus 2ac by a square of x plus alpha square, and alpha square into beta square is how much? It's c square by a square, that is equal to 0. So I can just multiply my a square in the numerator, so that gives me your ax square minus of b square minus 2ac of x plus c square equals 0. So ultimately that's what, there's a small mistake, sorry, that would be a square. So a square x square minus of b square minus 2ac x plus c square equals 0. So this is my final answer. Easy one, just manipulation of what we need from what we have got. Next, what can I find? Let's see. Yeah. Next question. My next question is basically, it says that it says that we have an equation that is your x square plus 5x minus 5 equals 0, whose again roots are alpha comma beta. Here we don't need to find an equation, therefore we need to find the value of 1 by alpha plus 1, this is whole cube, plus 1 by beta plus 1, this is whole cube. So this is what we need. This can be done in probably two ways. One is by using normal weighted ratios, and another one is using symmetric functions. So symmetric functions I would be coming afterwards. So now let's just focus on Vieta's relations. Time to change the color. Let's try with orange. Yeah. X square plus 5x minus 5 equals 0. Again, my roots are alpha and beta, so alpha plus beta is basically minus b by a. Here a is 1, so it's minus 5, and my alpha beta is your minus 5, again that's c by a. What do we need? We need 1 by alpha plus 1's whole cube plus 1 by beta plus 1's whole cube. So time to think, how can we solve this? Okay, so let's just vulgarly manipulate it. This is my addition, so what would be in my denominator? Alpha plus 1 whole cube into beta plus 1 whole cube, and my alpha plus 1's whole cube, so it will be beta plus 1's whole cube plus again alpha plus 1's whole cube. So we will be expanding the numerator. First of all, my denominator, I can take my cubic to be common, so we can write this as alpha plus 1 into beta plus 1, this totals whole cube, and this form. So beta plus 1 whole cube. We know the formula of a plus b whole cube. That is a cube plus b cube plus 3ab into a plus b. We apply the same one here. So a cube, that means my beta cube, plus b cube, that is means 1 cube plus 3ab. So that is my 3 into beta into 1 into alpha plus beta. That is your beta plus 1. Similarly, for my alpha plus 1's whole cube, that is basically giving me okay, alpha cube plus 1 cube plus 3 alpha into alpha plus 1. Time to just rearrange things. So we'll be arranging the alike things. How? Alpha cube and beta cube, I have brought it together, plus what are we left with? So alpha cube, beta cube is done, alpha cube is done. So 1 cube plus 1 cube, that is your 2. That is also done. Now we are left with 3 beta into beta plus 1 plus 3 alpha into alpha plus 1. So basically we can take my 3 to be common. So my 3, we take my 3 to be common. So that is your alpha into alpha plus 1 plus beta into beta plus 1. And below we have the same one, alpha plus 1 into beta plus 1's whole cube. Okay. Just simplify it. Alpha cube plus beta cube remains as it is. Plus 2 also remains that it is, plus 3 into. So alpha into alpha plus 1, that gives me alpha square plus alpha. Similarly, beta into beta plus 1, that gives me your beta square plus beta. And in my denominator, what do I have? Alpha plus 1 into beta plus 1. That is your alpha beta plus alpha plus beta plus 1. This is whole cube is what we have in my denominator. Okay, so what we have? We have alpha plus beta to be minus 5 and my alpha beta to be minus 5. Okay, so these are the things we have. And what do we need to find out from this? We need alpha plus beta is minus 5 and alpha beta is minus 5 again. These are the information which we had. We need to calculate this. So from here, what do we need? The information, additional information which can be calculated by manipulating these two equations is my alpha cube plus beta cube, alpha square plus beta square. So these are the two things which are needed. Cool. Yes. So let's start with alpha cube plus beta cube. Similarly, my alpha plus beta, as we had done the previous question, alpha plus beta whole cube is basically your alpha cube plus beta cube plus 3 alpha beta into alpha plus beta. So my alpha plus beta is basically your minus 5. So minus 5's whole cube is minus 125. Alpha cube plus beta cube is needed. So alpha cube plus beta cube, let it remain, plus 3 into alpha beta. So minus 15. So this is my 3 into minus 5 into minus 5. So then it is minus 125 is equals to alpha cube plus beta cube. This is 5 square 25 into 375. So then my alpha cube plus beta cube comes out to be minus 200. This is my main equation 1. And we need also alpha square plus beta square. So my alpha square plus beta square would be, sorry, So my alpha plus beta whole square, we know alpha square plus beta square plus 2 alpha beta, alpha square plus beta square plus 2 alpha beta. And my alpha plus beta is minus 5, so minus 5 square is 25, so alpha square plus beta square is needed. So plus, what do we need? 2 alpha beta is there, so 2 alpha beta, we can just, what to say, put it in. So alpha beta is minus 5, so that's your minus 10. So therefore my alpha square plus beta square is minus 35. This is my equation 2. Yeah, so what we need? This 2, right? I will just put it in here with a different pen's color because I need the equation on my screen too. So draw red. So my alpha cube plus beta cube comes out to be minus 200. My alpha square plus beta square comes out to be minus 35. Sorry, this won't be a minus, this would be a plus. Yeah. What do we have? What do we need? So alpha cube plus beta cube. We will be just putting on the value. So minus 200 plus 2 plus 3 into alpha square plus beta square is how much? That is plus 35 plus alpha plus beta. That is your minus 5. Minus 5 by alpha beta. This is minus 5 plus alpha plus beta. Again minus 5 plus 1 whole cube. So minus 200 plus 2 plus that is 3 into 30, that is 90 by minus 10 plus 1 minus 9's whole cube. So minus 200 plus 92 by minus 9's whole cube is minus 729. Minus 100 plus 92, that's basically your minus 100 plus 100 gives me 100, so plus 92, that gives me 108 by, so minus 108 by minus 729, so my minus and minus gets cancelled, so this one is also divisible by 9, so 9 ones are 9, 1 2, 12 9 is 108, yep, and this was my 81, so this I can divide by 4 and this I can divide by 3 and this I can divide by 3, that gives me 27. So ultimately my answer after a total manipulation is 4 by 27. Just take my bottle up. Second. That's the second base. So my next question, what do we have for the next question? Which one can I take? I need a good question. Okay, so yeah, this looks a little bit manipulative. I can take this one. Somebody had just knocked up on the door, so I had gone to check. My next question, I have my equation ax square plus bx plus c equals 0. Just a second, guys. Yeah. So my roommates had just come out. So my ax square plus bx plus c equals 0. Again, it has two roots, alpha and beta. Similar question, both of which are different from half. Okay. So given both of which are different from half, so alpha and beta both are not equal to half. Then we need an equation whose roots are 1 by 2 alpha minus 1 and 1 by 2 beta minus 1. So similar question, a bit of a bigger manipulation. Let's start. So my ax square plus bx plus c equals 0. So roots are alpha and beta. So again, alpha plus beta is my minus b by a as by beta relations, and my alpha beta is c by a. We need 1 by 2 alpha minus 1 plus 1 by 2 beta minus 1 and 1 by 2 alpha minus 1 into 2 beta minus 1. This is basically the product of both the roots. I am just combining the denominator, I mean numerator, and writing. We need this too. So therefore 1 by 2 alpha minus 1 plus 1 by 2 beta minus 1. Simple addition. So in my denominator I will be remaining with 2 alpha minus 1 into 2 beta minus 1. So here I have my 2 beta minus 1 plus 2 alpha minus 1. So I can take my 2 common. So alpha plus beta and minus 1 that gives me 2. And my denominator I will be multiplying this. How? So 2 alpha into 2 beta, that gives me 4 alpha beta, minus 2 alpha beta into 1, that is your 2 alpha, minus of 2 beta into 1, that is your minus 2 beta, minus of 1 into minus of 1, that is your plus 1. So 2 into alpha plus beta minus 1 by 4 alpha beta minus of 2 into alpha plus beta plus 1. Good. We don't need to calculate anything extra. We can just put in the values. Alpha plus beta is minus b by a. This needs a careful manipulation. 2 into minus b by a minus 1 by 4 into c by a as alpha beta minus 2 into minus b by a plus 1. So that is minus 2 into b by a plus 1 by 4c by a plus 2b by a plus 1 equals I'll be keep manipulating this. How? So minus 2 into b by a plus 1. So that is your a plus b by a. I'm adding them. So here also I can add them a. So I am left with 4c plus 2b plus a. So with this a and this a will be getting cancelled when I will be flipping the fraction. So minus 2 into b plus a by 4c plus 2b plus a. So this is the addition of the roots, and next what we need is 1 by 2 alpha minus 1 into 2 beta minus 1. Product we had just now calculated out. So 1 by again 4 alpha beta minus 2 alpha minus 2 beta plus 1. Cool. So 1 by 4c by a minus 2 into alpha plus beta. So minus 2 into minus b by a. So that is your plus 2b by a and plus 1. Ultimately, this is my a into 4c plus 2b plus a. This is my constant term. Therefore, my new equation would be x square minus of 1 by 2 alpha minus 1 plus 1 by 2 beta minus 1 of x. This is my summation of the roots plus my product of the roots, that is 1 by 2 alpha minus 1 into 1 by 2 beta minus 1. This result, what had I got? Minus 2 into b plus a. So this was now minus 2 into b plus a by, this is a bracket, okay, this is my bracket, by 4c plus 2b plus a of x plus my constant term, which was the product of the roots, that was your a by 4c plus 2b plus a, that gives me 0, equals, the denominator is 4c plus 2b plus a, we're multiplying them, so basically 4c plus 2b plus a of x square minus minus plus, so plus 2 into a plus b of x plus a equals 0. So this is the final answer. A bit manipulative, absolutely manipulative, not about that. I'll also be doing some discriminant related questions, but before that, I will just be giving you 3 pointers about how to find out about the roots through the discriminant. So my next topic of discussion is solving a quadratic equation, but this is only valid for quadratic, mind you. Solving a quadratic equation. Number 1, factorization method. My factorization method would be the easy one, which is your if, for example, x square minus 3x plus 2 is there, I will be middle term factorizing it, where I will be seeing the same thing of how we solve through weighted relations. That is, I will be seeing. So this is my product of the roots and this is my sum of the roots. So I will be taking two numbers whose product would be giving me 2, but my sum would be giving me 3. So basically this can be written as x square minus 2x minus x plus 2, since 2 plus 1 gives me 3 and 2 into 1 gives me 2. So I can take something common. So I can take my x common, x minus 2, and from here I can take my 1 common, so x minus 2. From both of this I can take my x minus 2 common. So ultimately this gives me your x minus 1 into x minus 2. So this is the factorization method. Number 2 is by integer root theorem or by rational root theorem. Usual ones, check for highest degree coefficient. Check for divisors of the constant term. Check for divisors of the constant term. These two are the things, and then again follow my rational root as I had said. I'm not going to revise it once more since I've done it already twice. In one full video was for rational root and theorem and its corollary, which was the integer root theorem, and before in the previous lecture also I had made you understand it once more. And number 3 is the great mathematician Mr. Guru Sridharacharya's formula, the quadratic formula. Sridhar Acharya or quadratic So here, what can I say? My roots would be, x would be a formula which we unfortunately need to learn. It was already done in my 7 and 8, so I'm just revising it once more. So it's minus b plus minus root over b square minus 4ac by 2a, or x is equals to minus b plus minus root d by 2a. This d is equals to b square minus 4ac is equals to the discriminant. So this is my discriminant. Now my solution, or the types of solutions which we can expect from a question, will depends on the discriminant. 3 cases. So next thing is how discriminant helps in root realization. That is in finding out the roots of the types of roots. 3 things. Give me 2 minutes. I will just be checking out something. Okay, so if my D is greater than 0, my D is less than 0, and my D is a perfect square. So if my D is greater than 0, then I will be having real roots. If my D is less than 0, I will be having imaginary roots. Since my quantity b square minus 4ac would be negative quantity, that means a negative inside root which would give me imaginary number. Imaginary root. And my perfect square, if my D is a perfect square, then I would be getting rational roots. That is a root in the form of p by q. For the corollary again, it can be an integer, but for that also perfect square is absolutely necessary. Rational root. So one question based on rational root then. So let's check my black one. Question, okay. My alpha is given to be a positive integer and the roots of the equation 6x square minus 11x plus alpha equals 0. Its roots are rational numbers. Roots are rationals. Therefore, I am going to give options since I have been given options in the book. Smallest value of alpha is option A is 4, option B is 5, option C is 6, and option D is none. So just if you want to solve it yourself, just pause the video and just do it. I want to give you 1 minute before I move on to the next screen. Okay, I guess all of you have solved it, or if you haven't, just pause it and solve. Solution. So my equation is 6x square minus 11x plus a equals 0. So this is not alpha a, this is alpha. We don't know anything about the roots, but we do know what will be the discriminant. That is my b square minus 4ac. And an additional hint that is given, that is my roots are rational. So it is pointing us that you use the properties of my discriminant. As I have said, if roots are rational, D will be a perfect square. So for my D to be a perfect square, what do I need? I need to find out my D. What is my D? That's b square minus 4ac. So here my b is minus 11. A is 6 and alpha is my c. So b square minus 4ac b square minus 4ac equals d. That gives me your d is equals to b square, that is minus 11 square, 121 minus 4 into 6 into alpha. So minus 24 alpha. Okay. I need to make it to a perfect square. So one thing is I can put my values of alpha given in the options and check it. At alpha equals 4, so 121 minus 24 into 4, 96. So 121 minus 96. This is my 25. At alpha equals 5. My 121 minus 24 into 5. That gives me your 120, so that's 1. And for my alpha equals to 6, my d becomes negative. So this is the perfect square, and for alpha equals 4. Okay, next. What more questions can I just give you guys? Okay, one more question, good one. Yeah. So do I have a nice question again? Draw. Put my black ink to work. My question says guys, I guess just a second. Yeah. Says we have an equation given 1 by x plus a plus 1 by x plus b equals to 1 by c. Good. Yeah. I'm given its roots are equal in magnitude, but opposite in signs. Then the product of the roots is. Then we need to find the product of the roots. Cool. How do we do this? So we'll be changing the color. My equation is 1 by x plus a plus 1 by x plus b is equals to 1 by c. We will first be converting this equation into the usual quadratic form of ax square plus bx plus c. To this, again take the LCM. So my x plus a into x plus b. Here we have my x plus b plus x plus a is equals 1 by c. So this is basically your x square plus ax plus bx, that means plus a plus b of x plus ab, and my top I have basically your 2x plus a plus b equals 1 by c. So I will be taking this to this side, this, and this to this side. So x square plus a plus b of x plus ab equals to 2x plus a plus b into c. So basically 2cx plus ac plus bc. So putting the like terms together to bring a quadratic in x. So x square. So this is there. So I will be taking my x common, a plus b minus 2c of x plus ab plus bc plus ac equals 0. This is my quadratic equation which has been formed. So what are we given here? This equation has its roots equal in magnitude, but opposite in sign. That means my usual roots are alpha and beta, but what am I given? Roots are equal in magnitude but opposite in sign, so alpha minus beta. So ultimately my summation of the roots becomes 0. So if my summation of the roots becomes 0, that means minus b by a is 0. So minus b by a is 0. That means here my a is 1 and minus of b. So minus of a plus b minus 2c is 0. So that means my a plus b equals 2c. So this is one relation. And the product of the roots, that is your minus of alpha beta. Okay. So second guide, this is related to symmetricity. We'll be teaching you tomorrow when I'll be wrapping this chapter up. So this is not for today. Symmetricity, but do remind me, I will be doing this in my next lecture, which is tomorrow. Do I have any more questions? Unfortunately, no. So we just practiced some questions today, and I taught you the concept of discriminant and how do you use discriminants. By knowing the roots, by knowing the discriminant, we can find out the quality about the roots. So yeah, that was all for today. Do contact me at my Instagram or my WhatsApp or anywhere in my blog channel too. Do follow my blog. I keep on giving regular updates both about my personal and professional and academic life and my channel. So that was all for today. We practiced some good questions, then we did solving a quadratic equation, we revised our Veda's relations, then practiced some good manipulative questions, easy ones but manipulative, which we can very well get confused under time pressure. So yeah, that was all for today. Lecture 3 ends up here. Tomorrow is the last lecture of polynomials, and after that I will be starting with my sequences and series, that is my AP, GP and HP. And I will be uploading a worksheet tomorrow in my description box for my tomorrow's lecture. So do keep a note at it. Tomorrow is going to be the final lecture of my polynomials. So yeah, that's all for today. Do like, share and subscribe the channel. Follow for more updates. Bye.